Hey everyone, and welcome back to this series on complex numbers. This is the second video in the series of complex numbers. The first video we did was we talked about what real numbers are, what natural numbers are, what other types of numbers there are, and that there are actually two types of numbers in math. One are the real numbers and other the complex numbers. Of course, in this video we're going to go beyond that. We're going to talk about how to find complex numbers, what is the standard form of writing complex numbers, what is the makeup of complex numbers, and we'll start with a little bit of background. So what we basically did before was, and what we have is that real numbers are basically a subset of large set of numbers called complex numbers. Now don't be confused by what I said before, that there are two types of numbers, real numbers and complex numbers. The thing is that any number can be a complex number, but any real number cannot be a complex number. What I mean by that is that first of all let's talk about this, and then I'll go beyond that, and then I'll explain to you what I actually mean by that. So let's do a little recap, and if you see over here, we will see that a complex number is any number that has an imaginary unit in it. By imaginary unit I mean in which has an under root of -1 in it, or a negative radical in it. If it has a negative radical in it, that means it will have an imaginary unit in it, and when it will have an imaginary unit in it, that would mean that it is a complex number. If you look over here, I will be under root of -1. So of course, if we shift the radical to the left hand side, we'll get I squared is equal to -1. These two identities, two equations that you have to understand in order to solve complex numbers. If these two get through to you, then it's really easy from here onwards. So let's move on. So this is pretty basic what we did over here. So we then looked at some examples, that how do we find the radical under root of -25. How we do that is that we two values inside the radicals. One is the negative value that we take -1, and then we multiply it by under root of 25. That way we will get -1, which is under root of -1 we know is I. We will take that outside the radical, and we will get 25 over here, and that is how we will find the answer 5i, because 5 squared is 25. The same goes for under root of -16. We first separate it into -1 and under root of 16. Under root of -1 will make I, and root of 16 will make 4i. Once this is solved, let's move on to new examples over here. Now if you look at these examples over here, these are pretty much the same type of examples that we did before. Now under root of -36, this is the same thing that we did. We don't have to write it again and again, that as under root of -1 multiplied by under root of -30 and under root of 36 in order to solve. Now we can do this intuitively. So we see that it is -36. In order to remove this negative over here, we will write I outside the radical. So that will remove the negative from inside the radical, and we will have I over here. So I would basically mean that this is under root of 36 and I on the outside. That will become 6i. So this is how you find the answer to this. Now let's just go and try and find the answer to this question over here, under root of -18, which is not a perfect square. So under root of -18, we'll do the first step. That is, we find out the first step that whether this is a negative radical, whether the answer would be a complex number with an imaginary value, or it won't be a complex number. In order to see that, we see inside the radical that it is a negative integer. Now since it is a negative integer, we know that the answer would be an imaginary one. We'll have an imaginary solution to it. So what do we do next? The step number 2 would be that we remove the negative sign, and in order to do that, we take out I outside the radical like this, and we're only left with the positive value under root 18 inside the radical. In case some people are wondering what is a radical, this under root sign over here, this is known as a radical. So we have under root 18 over here, 18 inside the radical. Now 18 can be broken down into 3 into 3 into 2. That is 9 into 2. So it can be written as 3 square under root of 2 multiplied by and 3 square multiplied by 2. So we can take out the 3 square and from underneath the radical, and we can get 3i over here and under root of 2. Now let's look at this funny example over here. Now this is a really unique example because it will really test your concepts, because this way you could know what is under root of -1. Now under root of -1, you don't have to write it down like we did over here, that under root of -1 is under root is I. What you need to do is you need to work it out. How do we do that? The first step is we recognize that this is going to be a complex number because there's a negative sign underneath the under root. Once we have recognized this, the second thing we need to do is we need to get rid of the negative sign. How do we do that? We remove the I from underneath the radical by removing the negative sign, and we get I under root of 1. After we are done with that, we are left with only one thing, and that is solving the radical. Now under root of 1 is 1, so we don't have to write it. So this is how 1i is written. Just like in algebra, x is written as 1x basically means as 1x. If you have a value of x that is more than 1 or less than 1, then you can write it down, but otherwise x basically means 1x. So just like that, I over here basically means 1i. Of course, I over here has a little more significance than x in algebra. Moving on. Now this is how complex numbers are basically represented. A complex number is basically a number that consists of a real part and an imaginary part. This over here, a plus bi, is known as the standard form of complex numbers. So a plus bi basically means that it will have a real part. That is, a real part is anything that does not have I with it, and it will have an imaginary part. Imaginary part is anything that has an I attached to it. Now if you look at it, you will have basically two integers over here. You can say you can have two real numbers over here, as the definition says so. One is a and one is b. However, b over here has an imaginary part attached to it. That's why this will make a complex number. So this is how a standard form is written in complex numbers: a real part with an imaginary part. Now if you look over here, b is equals to 0 would mean that there is no imaginary part. So we're only left with a over here. We're going to see examples of this in the next slide. We're only left with a over here. You can say in one way that this is a real number, just like 5 or 6 or 7. But another thing you have to remember is that this is a number which has an imaginary part is equals to 0. If someone asks you that is 5 a complex number, you can say yes, it is a complex number if the imaginary part is 0. However, there are many times when there is no discussion of imaginary parts, we only write it as a real part, that is 5. On the other hand, if it has like 5 plus 5i, we will call that a complex number with a real part and an imaginary part. On the other hand, what if there is no real part? What if a over here is 0 and all we have is bi? All we have is 3i or 4i or 5i. What would that be a complex number? Yes. That will be a complex number, but it will be called a pure imaginary number because it will have no real part whatsoever. So we can say yes, this is a 3i is a complex number which has a real part 0. So we don't need to mention it, so we'll only write it as 3i. Now let's look at examples of this in the next slide. If you look over here in the first example, that is negative 3 plus 5i, it is pretty clear that this is a complex number. Now because it has a real part of negative 3 and it has an imaginary part of 5. Imaginary part of 5, not 5i, because I is what defines an imaginary part. So I is what makes it an imaginary part. So this is how we're going to write it as 5. So we have this in the standard form and this is a complex number. Moving on. If you look at over here, we see that this is 2 minus 6i. Is this a complex number? Yes, this is a complex number. Why? Because it has a real part 2, a non-zero real part 2, and a non-zero imaginary part negative 6. So this will make a complex number with the real part and an imaginary part. Moving on. Now this is where it gets tricky. If you see 5 over here, okay. Now if in a question or if in an exam or anywhere you see that whether this is a complex number or not, if they say that this is a complex number, you can easily say, okay, this is a complex number. It has a real part 5 and its imaginary part is 0. Don't get confused by the fact that you don't see any I over here, because if it is in a standalone 5, you're not going to talk about complex numbers with it. You're just going to say, okay, this is a 5, this is 5, this is an integer, this is a natural number, this is a whole number, this is a real number. But if the question relates to complex numbers, you can say yes, this is a complex number with a real part 5 and an imaginary part of 0. And can we call it a real number? Yes, we can call it a real number because it has no imaginary part in it. In order for it to be a complex number, it needs to have an imaginary part. Now, if you recognize the fact that it has an imaginary part but you cannot see it because it is 0, then you can call this 5 complex number. Other than that, you can it can go as a real number or a natural number or any other number. So don't get confused by it. If the question is about complex numbers, you can say yes, 5 can be written as a complex number with a 0 imaginary part. On the other hand, if you're only talking about numbers in real life, you won't say that 5 in itself standalone is a complex number. You'll say it is a real number, it is an integer. Now 7i, what about this? As it is different from 5 over here, we'll see that it has I over here. So I in itself basically says that it is an imaginary part, it has an imaginary part. So this would basically mean that this is a complex number. You don't have to say that yes, this is a complex number which has a real part is equals to 0. You don't have to say that. You just say the real part is 0, imaginary part is 7, and 7 is a complex number. Just say that and you're done with it. 7i is a complex number, and it doesn't even matter what the discussion is about. It doesn't even matter what the question is about, because I in itself basically tells you that it is a complex number. It is a purely imaginary number, as we talked before. It only has an imaginary part in it. It has no real part in it, but it will still be called a complex number. It is not as confusing as 5, because we have to determine whether we're talking about complex numbers or we're talking about real numbers. Because if we're talking about complex number, that would mean that 5 is a complex number with a 0 imaginary part. On the other hand, 7i, since it has I in it, we can know that it doesn't even matter what we're talking about. It doesn't even matter what the discussion is about. We can just say yes, this is a complex number because it has an imaginary part, and this will be known as a purely imaginary part. This is all there is to the representation of imaginary numbers. This is called the standard form. Even this is a standard form, but only difference is that over here bi, as we saw over here in this slide over the bi, over here bi is 0 because b is 0, and over here a is 0 because we only have bi, and a is equals to 0. Now let's solve a question. Let's solve a simple question so that you will know how to find out complex numbers. So this we have an example over here. We need to solve this. We need to write down 7 plus under root of negative 45 in the standard form, that is a plus bi. Now let's solve this. What is the first thing that we do? We recognize that this has a real number. 7 is 7. We don't have to do anything about it. We just write it down as it is. So 7 will be 7. We just write it down as it is. The next thing that we need to understand is what is inside the radical. We see that inside the radical is a negative number. What is that? A negative of 45. So we now know that this would have an imaginary value. So we solve this. How do we do this? We write it the real part a, we take out the imaginary value, that is I, and then we solve for what is left inside the radical. This way we know, even this is a complex number right here right now. 7 plus I under root of 45, this is a complex number. That's it. You're done with the question. You just took out the negative from the radical and you have your answer over here. So that is all you needed to do. But we need to simplify it further, because remember this, that the more you simplify, the more you're going to understand, and the more beautiful it will look. I mean, and that's not really important, but that's how math should be done. So 7 once again plus I, of course, and now we have the under root of 45. So what is going to be the under root of 45? Well, we know that 9 multiplied by 5 is 45, so we can write it down as 3 into 3 into 5, which can be broken down into a standard form complex number, and which can be written down as 7 plus 3i under root of 5. So this is your answer right here, 7 plus and 3i under root of 5. This is your answer right here. Simplify it to the form, well, not to the maximum form, because you can still find out the under root of 5, but it's going to be the answer is going to be in decimal form. But I just don't want you to solve it right now. All I want you to do is to understand how to find the answers. So this is how it's done. The real part was real part. We didn't have to do anything about it. And for the radical, first step was to find out whether it's a negative one or a positive one. We knew it was a negative one, and because it's a negative one, we know that it's going to be an imaginary value. Once we're done with that, we take out the negative in the form of I outside the under root. Once we're done with that, we solve the radical, and that will be 3 multiplied by 3 multiplied by 5, because 9 multiplied by 5 is 45. Once we're done with that, we have 7 plus 3i under root of 5, and this is the answer to your question. So that's pretty much it for this video. We're going to continue the series on complex numbers. We're still in the introductory phase. When we're done with that, we'll move on. But this is it for now. Hopefully you guys will join me in the next video as well. Thank you very much.